Now let's look at the correct method for refueling a pressurized tank system and how the individual components are intended to function. The service person will attach the fuel nozzle to the receiver, ensuring the rotating handle is in the off position. The actuator is retracted during this process, then released to ensure that the nozzle is locked to the receiver. The service person will pull back on the nozzle handle to confirm it is locked into position. Then we'll walk over to start the fuel pump. Once the pump has started, the service person will go back to the fuel nozzle and rotate the handle into the on position, allowing the diesel fuel to flow. For a pressurized fuel tank design, it depends on the pressure on the receiver side being greater than the pressure on the fuel delivery side of the receiver nozzle connection. Here is the equation which shows all the opposing forces happening as the fuel tank fills up. On the delivery side, we have the dynamic fluid pressure and the fuel nozzle spring force. On the receiver side, we have the system head pressure, the receiver spring force, and the overall tank pressurization. As the fuel level rises, the system head pressure increases, acting against the nozzle. However, the constant force of the fluid flow and the nozzle spring are still greater, and the fuel nozzle remains open. The air in the tank is able to be displaced via the tank vent, as shown. The fuel level has now reached the float valve, which will close the main orifice for air to escape. Displaced air is now restricted to the pressure relief valve and bleed hole, which displaces air at a slower rate. The pressure within the tank will quickly rise, which will ensure that the forces acting to close the nozzle are greater than the forces opening the nozzle. The piston within the nozzle will then push the spring, and the handle will automatically rotate into the off position. The tank pressurization will be reduced as the pressure relief valve and the bleed hole in the tank vent slowly equalizes pressures back to normal. All fuel tanks are designed to have a minimum ullage, defined as the amount by which a container falls short of being full. For diesel containers, minimum ullage shall be 5% of the tank volume. With the tank now filled to the correct level, the service person then shuts off the fuel pump and removes the fuel nozzle from the receiver. Let's rewind back to the start of the process to show common causes of incidents and how they can be rectified. First, we'll see what happens when the refueling components are mismatched or incorrect for the mobile equipment specifications. Here we have two different tank setups, one with a shorter tank and receiver mounted directly onto the tank, and another much larger tank with the receiver mounted some distance away, connected by a hose to the tank. In this case, we have the same receiver installed on both systems, which is only intended for the smaller tanks. As the fuel level rises, you can see that the system head pressure increases steadily for both, but there is some additional pressure acting against the nozzle in the example with the hose connection. We see that when the smaller tank is full, the tank starts to pressurize and the nozzle shuts off as intended. However, the larger tank is reaching similar pressures, and so the nozzle will shut off before the tank is full. Because of the different tank configuration, this setup needs to have a lighter receiver spring setting, so the tank does not reach pressures required to shut off the nozzle before becoming full. Now let's consider the case where the receiver is the correct model for the mobile equipment, but the service person tries to add a bit extra. The service person will see that the fuel nozzle has shut off, but from the outside, they cannot be sure if it is truly full. We see a similar situation with our cars when we fill them up at a service station. Whenever the fuel nozzle clicks off, we often give it one or two more squeezes to be sure. However, with a quick fill setup, and often set to 800 litres per minute when the tank is full, there is usually very little ullage left in the tank. Rotating the nozzle on again will result in mere seconds before the tank becomes 100% fuel, and having small amounts of fuel being displaced through the tank vent. There is a danger of overpressurization or even tank rupturing with these practices. It is a common misconception that the overflow hose, seen on many machines, is there to displace fuel when the tank is full. This is not the case. In reality, the hose is only intended for air. It is directed away from the engine bay as it can still contain traces of fuel in air, which is able to ignite on hot surfaces. Now let's consider one final case where the tank vent is mounted too high on the tank, or it is an incorrect model, We see here that the tank vent is mounted higher than normal and is a short model. This means that the float valve orifice sits very close to the top of the tank. With the fuel level reaching the float valve and shutting off the nozzle, there is very little ullage present. Although the fuel nozzle shut off in time, this configuration leaves very little time before fuel spillage or overpressurization can occur. The float valve should be mounted such that the ullage at the point of shutoff is a minimum of 5% of the tank volume. After investigating the primary incident and other possible refueling scenarios, the following key lessons were discovered. Never tie off or manually hold the automatic fuel nozzle shutoff, as pressurized fuel systems rely on back pressure to switch off the nozzle. Where nozzles are unable to switch off as designed, fuel spillage or tank rupture can occur. Always ensure that the fuel delivery components and the fuel receiving components match, including component manufacturers and settings. Unique mobile plant requirements must also be considered, such as fuel tank size and location of the receiver. Always ensure that any personnel undertaking fast fill refueling activities are aware of the technical specifics of all fuel delivery components, that they understand the hazards and the function of critical safety controls. Whenever it is noticed that the fuel nozzle shuts off prematurely or if fuel is leaking from the overflow hose, always contact maintenance to rectify the issue. Do not utilize any workarounds. The consequences of doing so could result in significant safety incidents and loss of equipment.